Hello, thanks for taking time to listen to this presentation. My name is Liang Jiang. I'm going to be introducing my work, The Prediction of Lifetime Dementia Risk. Dementia is a neurodegenerative disease that affects almost half of senior people. According to a report from Alzheimer's Association, 40 million people will be living with dementia by 2050, and $300 billion each year spent on taking care of those patients. 30% of seniors die with this disease. So it's one of the biggest challenges for our society. The worst thing is that we don't have any effective cure methods yet for this disease. So we won't be able to get that much help from a doctor. A lot of people think that dementia is just a natural aging process. However, many researchers have shown that if we take some active preventions, we could definitely reduce its risk. In order to do so, first, we need to know if we have this risk or not in our life. As we can see in this plot, different people have different risks in their life. And then we need to know what we can do to slow down this process. For instance, in this case, if the person get rid of the smoking, depression, hypertension, etc., this curve gonna be flattened or not. And this is a lot of work a doctor can do with their professional skill or knowledge, because we need to use large amount of data to build a useful model, predictive model. Let's see how it works. First, I did some pre-processing on the data I have, such as feature engineering, feature selection, and PCA analysis. And then I fed the data into a machine learning pipeline, such as data splitting, model selection, and model interpretation. And finally, I use a model to develop an app to help people predict their lifetime dementia risk. The data I used is OSS3 collected by Washington University over 15 years, and it's 4,000 longitudinal data for 1,100 participants. In this case, for each participant, we have about 10 years data. And the features I used include demographics, genetic data, family and health history, as well as behavioral assessment data. And the label I used is standard clinic dementia rating, which is equivalent to the brain healthy score I used in this work. The machine learning pipeline I used in this work includes the data normalization, data splitting, model selection, research and cross-validation to turn the parameter, and the last is model evaluation. And here's the result for different methods. With random forest achieved the best performance with a correlation of 0.54. As you may have noticed, our model performance is not quite good. One of the main reasons is that we don't have enough data. So I was wondering if I can artificially increase the data to improve the model performance. As you can see, there's a good relationship between the CDR and the age, and we only have 10 years data for each participant. So I extrapolated the data to older ages by assuming there's no change for other information. By doing so, I improved the model performance from 0.54 to 0.71. And if I remove some of the outliers, the model performance increased to 0.86. The feature importance analysis from random forest shows that the top risk factors for dementia are the age, GTS, BMI, education, etc., which is consistent with our understanding on this disease. And here are two examples on how the GTS and the ApoE genes affect our brain healthy, which also proves that our model is correct. Let's see how the app works. So with the user's information such as their age, the weight, the smoking years, GTS, etc., and then we can predict their brain healthy score and what are their top risk factors and how their brain health is going to be decreased with increased age. So in this, to summarize, in this project, I developed an app to predict the lifetime dementia risk for users and also help them assess what are the top risk factors for them. By doing so, we expect to slow down the process of developing this disease and also may help doctors to make a better evaluation. At last, I want to reintroduce myself. My name is Liang Jiang. After I graduated from school with a master's degree in geophysics, I started to work in an oil company for several years. And then I went back to school to pursue my PhD at the University of Houston. In past decades, I've been using large amount of time series data to build predictive models to solve challenges in oil industry using machine learning, signal processing, imaging technique, as well as wave series, etc. Now I'm very excited to leverage the knowledge and skills I have learned to solve any challenges we may have in data science field. Thank you for your attention, and please feel free to contact me if you have any further questions on this talk.